Hello, mathematicians. In this lesson, we are going to go over 3 probability laws. The first one will be about mutually exclusive events. Then we'll move on to compound events. And finally, we will look at independent events. In this video, we're going to talk about exclusive events. So, the first definition is for mutually exclusive events. An event or two events are considered mutually exclusive if they cannot both occur at the same time. So some examples of this could be the event of rolling a 6 with the event of rolling a 3. If I have a standard 6-sided die, I cannot have both a 6 and a 3 occurring at the same time. Another example of mutually exclusive events is that it cannot both be day and night at the same time. It's either daytime or it's nighttime. We can represent mutually exclusive events in a Venn diagram that contains disjoint sets. That means that the intersection between the two sets is empty. The formula for this is that the probability of event A or B occurring is simply equal to the probability of event A occurring plus the probability of event B occurring. In other words, if there is a Venn diagram showing two events, we know that the intersection space is actually empty. So the probability of both A and B occurring is 0. So here we have two mathematical ways looking at probabilities to figure out if two events are mutually exclusive. The first one is that if the probability of A or B occurring is equivalent to the probability of A plus the probability of B. And the second way is looking at the intersection, and if the intersection has a probability of 0, then we know the event is mutually exclusive. Let's look at a worked example. In a race, the probability that Mikhail wins is 0.3. The probability that Elliot wins is 0.2, and the probability that Ken wins is 0.4. Assume there are no dead heats. First, we need to find the probability that Mikhail or Elliot wins. Now note that these are mutually exclusive events. We cannot have two winners. There's only going to be one. So we know that the probability of Mikhail or Elliot winning is going to be 0.3 plus 0.2, since we have already decided that these two events are mutually exclusive. So either one winning, the probability would be equivalent to adding their independent probabilities of winning together. The next one, the probability that neither Elliot nor Ken wins. Here's a mathematical notation that we use to denote that sentence. Now we want to find the probability that neither Elliot nor Ken wins. We can use this notation to show that event. And the probability of neither Elliot nor Ken winning is going to be equivalent to 1 minus the probability that Elliot wins and Ken wins. So what's left over is 0.4. Please try the next question. All right, let's check our answers. Okay, folks, now it is time to try some practice problems on your own. So go ahead and try these. Check with a friend or a partner when you're done.